Hello everyone. In today's lecture we will see LU decomposition method to solve the given system of linear equations. We'll discuss LU decomposition method. Okay, L is your lower triangular matrix, U is your upper triangular matrix. Okay, so the algorithm is as follows. Okay, we want to solve for x, that is Ax is equal to b. We need to find x, which is your solution matrix. A is your coefficient matrix and b is your constant matrix. In the last class we discussed all these notations. So the first step is decompose the coefficient matrix A, decompose the coefficient matrix A into product of lower triangular matrix L and upper triangular matrix U and find L and U. Okay, the first step is the most important step. First step says decompose or break the coefficient matrix A as a product of L and U and find L matrix and U matrix. Okay, for example, if you take a 3 by 3 system, if you take a 3 equations and 3 unknowns, okay, a 3 by 3 system, so you'll get A matrix as A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay, so L and U also should be a 3 by 3 matrix. Okay, so here this is your lower triangular matrix. Below the diagonal elements only the elements will exist. Above the diagonal elements all elements are 0. And this is your upper triangular matrix. Above the diagonal elements only you have the non-zero elements. Below the diagonal elements all the elements are zeros. Okay, so you should decompose the matrix into like this, into product of L and U, and you need to find L matrix and U matrix. Okay, here if you notice I have taken the diagonal elements of lower triangular matrix as 1. Okay, so this approach is known as Doolittle's approach. Okay, Doolittle's approach. Okay, suppose if you keep the diagonal elements of the lower triangular matrix as L11, L22, L33, and if you put the upper triangular diagonal elements as 1, 1, 1, that is known as Crowd's approach. Okay, any approach you will get the same solution. Okay, don't worry, normally follow Doolittle's approach for your examination. In real time we are not going to solve any system of linear equations on paper. We will use softwares like Matlab, there are so many other programming softwares in which we will use that software to solve the given system of linear equations. Okay, so in Doolittle's approach we will keep the diagonal elements of lower triangular matrix as 1. Okay, so in this way you will decompose and you will find all the elements of the lower and upper triangular matrix. Okay, so just do the product multiplication, matrix multiplication. It's very simple. First row you will get, when you multiply you will get first row as basic multiplication. You'll get the coefficient matrix is equal to, okay, U11, U12, U13. Okay, so when you do the matrix multiplication, 1 times U11 to get the first row, first column element, 1 times U11 is 1, 0 times 0 is 0, plus 0 times 0 is 0. Okay, next first row second element, first row into the second column corresponding elements. So 1 times U12 is U12, plus 0 times U22 is 0, plus 0 times 0 is 0. So when you do that product matrix multiplication you will get this matrix. Okay, so compare you know A11, A12, A13, all these elements you know. Now find this unknown values. Okay, so when you compare, U11 is equal to A11. Okay, so U11 is A11, U12 is A12, U13 is A13. Next compare the second row with this second row elements of coefficient matrix and find L21, L21 and U22, all other elements. Okay, we'll do one problem then you will understand. So by comparing, find all the elements of L and U. Okay, so this is your first step. Decompose the matrix A into product of L and U. Keep the diagonal elements of lower triangular matrix as 1. Okay, it is a Doolittle's approach, and find all the elements of L and U. Okay, so once you do that, second step, Take any arbitrary matrix y, okay, y is also a variable matrix whose order is equal to x, okay, so that Ly is equal to b, okay. From the first step, you know the L matrix, you know the B matrix is given in the problem. Y matrix is any arbitrary matrix which takes the order of x, okay. So by forward substitution, find the Y matrix, okay, find Y matrix, okay. Step 3, put take ux is equal to y. From step 2, you know y, okay. U from step 1, okay. Now you need to find x, so by doing backward substitution, find the value of x, okay. So this is our task, finding the x is our task, okay. So find x by backward substitution. So in just 3 steps you will get the solution, okay. So the proof of this method is very simple, okay. Ax is equal to b is the given equation. You want to find x, okay. We want to solve for x, okay. So what we did, first step, we decomposed A as a product of LU, okay, product of L matrix and U matrix. So when I substitute that, I will get LUX is equal to b, okay. Let this be your second equation, okay. Now take ux, now take ux is equal to y, okay. Let this be your 3. Now put 3 into, so when you put ux is equal to y here, you get ly is equal to b, okay. Ly is equal to b, okay. So you know b, you know L, okay. So solve for y, okay, and put y in equation 4, okay, this equation 3, sorry, in equation 3. So ux is equal to y. So you know y, you know u, so you can find x, okay. So in the next class we'll do one problem on LU decomposition method, so that you will understand this method very well. Thank you.